In this video, we'll talk about network intrusion detection systems. Network intrusion detection systems are often referred to as NIDS. It's designed to look for inappropriate or unauthorized use, specifically on a network as opposed to a specific host on the network. So it can be configured to compare data, that's current activity data, to known threats on the network, or it can be configured instead of or in addition to compare current activity data on the network to a baseline of normal activity. But much as is the case with a host intrusion detection system, a network intrusion detection system has to have an existing baseline of normal activity. And what's normal on a network within one company will be different from what is normal on a network for a different company. So it is specific to an organization. We need to consider the placement of the NIDS on the network. So for instance, if we want our network intrusion solution to be able to monitor all network traffic, we must make sure it's placed appropriately so that it can see all network traffic. So if we're specifically doing this for internet traffic, inbound and outbound, we'll probably want to make sure that our NIDS is in the middle of the connectivity between our internal network and the internet. In the case of network switches, we might have to plug our network intrusion detection system into a specific switch port, and the switch administrator might have to configure port forwarding or copying of data for all ports to the one that the NIDS is plugged into. Just like with host intrusion detection systems, a NIDS could be a hardware appliance, or it could be software installed in a server operating system, or it might be a specialized operating system, an appliance essentially, whether it's virtual that you run in the cloud or a virtual appliance that you run on premises. The network intrusion detection system needs to be trained for your specific environment, again, similar to a host intrusion detection system. Many NIDS solutions will have a learning mode where essentially you can configure it to monitor activity for a period of time to establish a baseline of normalcy in your environment. You can also, instead of or in addition to, normally it's in addition to, configure specific rules for what is considered suspicious network activity and what to do about it. And also, you can tweak it to eliminate false positives. On the encrypted network data level, generally speaking, network intrusion detection systems can't examine encrypted data. Now, of course, as always, there are exceptions to every rule. There are some NIDS systems that will allow you to specify decryption keys in various forms so that they can examine encrypted data, but generally speaking, this is not the case. So we might have one solution that does allow us to enter perhaps a symmetric key or phrase, or even to import a PKI certificate for decryption. A NIDS looks for various hints of abnormal network activity, and that's going to include things like reconnaissance. Reconnaissance is one of the first phases an attacker would undertake before they start to try to exploit vulnerabilities. That basically it's learning for the malicious user about what's out there. This can be done through ping sweeps to determine which hosts are actually up and running on the network, or conducting port scans to identify which network services are running on hosts on the network. Also, it includes Snmp scanning. Snmp stands for Simple Network Management Protocol. This has been around for decades, and it's a way for us to use a management station to query information about a network device, whether it's a server, a router, a switch, and so on. So we can get statistics through Snmp by querying an Snmp MIB, Management Information Base, or in some cases, Snmp can also be used to write configuration changes over the network to network devices. Snmp normally occurs over UDP port 161, so that might be something we want to consider when configuring packet filtering rules. Network exploits essentially can be determined because a malicious user will normally try to test discovered targets for weaknesses, and that might not be normal activity against a service. So for instance, running a telnet session to poke and prod at an HTTP server instead of actually issuing a standard HTTP GET request to retrieve information from the web page could be an indicator of suspicious activity. We might also have a NIDS that looks for hints of denial of service attacks. A denial of service attack, or DOS, essentially is excessive traffic or activity on a specific host beyond normal usage. Now, that might be executed by locally installed malware, or it might be executed even over the network. Common network intrusion detection products include the Snort open source tool, Alien Vault Unified Security Management, or USM, and Semantic Net Prowlers, among many solutions. In this video, we talked about network intrusion detection systems.